Look up at the night sky. That faint, glowing river of stars stretching across the darkness, that is not just something beautiful to look at, it is our address. For most of human history, we believed those stars were distant decorations, random lights scattered across an infinite sky. But science revealed something far more unsettling. Those stars are part of a single structure, a vast, rotating system called the Milky Way galaxy, and Earth has always lived inside it. But now, imagine something almost impossible to picture. Imagine that Earth was never part of the Milky Way at all. No spiral arms above us, no neighboring stars shaping our sky, no galactic home quietly holding us in place. Not ripped away, not destroyed, just never there. What kind of planet would Earth become if it were born alone in the universe? Would life still exist? Would intelligence ever emerge? Would the night sky even look like a sky at all? This is not a story about explosions or instant death. It is a deeper, more unsettling story. A story about how location determines existence. Because it turns out, Earth's survival was never just about the sun or the moon or even the laws of physics. It was about where we were born. A galaxy is not just a collection of stars, it is an environment. Just like Earth's oceans, atmosphere, and magnetic field create the conditions for life to exist, the Milky Way creates the conditions for planets like ours to exist at all. It supplies raw materials, it regulates radiation, it shapes gravity on enormous scales. And without it, the universe becomes a very different place. Colder, emptier, more hostile. Tonight, we are going to remove Earth from its cosmic home. Not violently, not dramatically, but completely. We are going to imagine a universe where Earth formed outside any galaxy. In the vast darkness between galaxies, where stars are rare, where matter is thin, and where time itself feels different. By the end of this journey, one thing will become clear. Earth's greatest protection was never its atmosphere. It was never the oceans. It was never even the sun. It was the galaxy we were lucky enough to be born into. What the Milky Way really provides. The Milky Way is not just a collection of stars. It is a system, a massive, rotating structure made of more than 100 billion stars, bound together by gravity and something even more mysterious, dark matter. From the ground, the galaxy looks calm, peaceful, almost decorative. But in reality, it is constantly moving. Our sun is not standing still. It is traveling around the center of the Milky Way at nearly 500,000 miles per hour, carrying Earth with it on a journey that takes about 225 million years to complete just once. That means the last time Earth was in this exact position in the galaxy, dinosaurs had not even appeared yet. This motion matters, because galaxies are not empty neighborhoods. They are environments, just like oceans, forests, and atmospheres. And the Milky Way provides three critical things that Earth quietly depends on. First, material. Every atom heavier than hydrogen and helium was foraged inside stars. Carbon, oxygen, iron, calcium, the elements that make up your body, the planet beneath your feet, and the air you breathe did not exist in the early universe. They were created through generations of stars living and dying inside galaxies like ours. Without the Milky Way, there would be no steady supply of these materials, no rich planetary cores, no stable crusts, no complex chemistry. Earth itself might never have formed. Second, protection. Space is not gentle. The universe is filled with high-energy radiation, particles moving at near light speed, capable of tearing through DNA and stripping atmospheres. The Milky Way acts as a buffer. Its magnetic fields, gas clouds and overall structure help absorb and scatter some of this radiation. Not all of it, but enough to matter. Inside the galaxy, radiation is distributed unevenly. Some regions are violent, others are relatively calm, and Earth formed in one of the calmer zones. This region is known as the galactic habitable zone, not too close to the chaotic galactic core, not too far into the thin outer edges, a narrow band where stars live long lives, supernovae are rare, and planets can remain stable for billions of years. This was not guaranteed. It was luck on a cosmic scale. Third, stability. Galaxies provide gravitational order. The combined mass of stars, gas, and dark matter creates a deep gravitational well. That well keeps stars on predictable paths and reduces violent disruptions. Without it, stellar systems can drift unpredictably, or worse, they can be torn apart. The Milky Way's gravity helped keep our solar system stable long enough for life to slowly emerge. No sudden encounters, no catastrophic ejections, just time. And in the universe, time is everything. Now here's the key realization. Earth didn't just need a sun, it needed a galaxy that behaved itself, one that wasn't too active, too chaotic, too empty. The Milky Way provided a balance that is rare on cosmic scales, and that balance shaped every chapter of Earth's story, long before life ever existed. So, when we ask, what if Earth was never in the Milky Way, we are not asking a small question. We are asking what happens when you remove the environment that quietly made everything else possible. A lonely birth outside the Milky Way. Now let's remove Earth from the story entirely. Not violently, not dramatically. Just imagine this instead. Earth is never born inside the Milky Way. No spiral arms forming around it, no dense clouds of gas and dust nearby, no generations of stars living and dying in the background. Instead, Earth forms in the vast space between galaxies, intergalactic space, a region so empty that, on average, you could travel for millions of miles and encounter almost nothing at all. No bright stars, no glowing nebulae, just darkness and extreme isolation. Here's the first problem. Stars don't like forming there. Inside galaxies, gas clouds collide, they compress, they collapse under gravity. That's how stars are born. But outside a galaxy, matter is thin, spread out, and rarely disturbed. Without frequent collisions, clouds don't collapse easily. Star formation becomes incredibly rare, which means something critical disappears: heavy elements. Earth is not made from the universe's original ingredients. The early universe contained almost nothing but hydrogen and helium. Everything else came later. Carbon for life, oxygen for water, iron for planetary cores. All of it was forged inside stars and scattered through space by supernova explosions. If Earth had formed alone far from stellar neighborhoods, those materials would be scarce or missing entirely. A planet might still exist, but it would be poor, chemically simple, geologically weak. No thick crust, no magnetic field strong enough to last, no long-term protection. Now consider Earth's atmosphere. Our atmosphere exists because of a delicate balance between gravity, geology, and stellar influence. Too little mass, and the atmosphere escapes. Too much radiation, and it gets stripped away. Inside the Milky Way, Earth benefited from a steady environment. Outside it, high-energy cosmic rays would hit unfiltered, constantly. They would chip away at the atmosphere, particle by particle. Over time, oceans would evaporate, gases would be lost to space. Earth would become dry, silent, exposed. Even if water somehow remained, life would face overwhelming odds.
Radiation would damage DNA faster than evolution could adapt. Mutation rates would spike, extinctions would be frequent. Life wouldn't slowly climb toward complexity, it would stumble, restart, and fail again and again. And the sky? The sky would be nothing like ours. No bright band of stars, no constellations, just a few faint points of light, distant galaxies so far away they barely glow at all. No cosmic landmarks, no sense of scale. The universe wouldn't feel vast, it would feel empty. So if Earth had never been part of the Milky Way, it wouldn't just be different, it would be fundamentally diminished, not destroyed by violence, but weakened by isolation. And that leads to an even more unsettling question. Even if life somehow survived, would intelligence ever appear?
Radiation, survival, and a hostile universe. Life does not fail quietly. It fails under pressure. And outside a galaxy, pressure comes from everywhere. The universe is filled with cosmic radiation, high-energy particles born from supernovae, colliding galaxies, and violent events billions of light-years away. Inside the Milky Way, much of this radiation is filtered, scattered by gas clouds, deflected by magnetic fields, absorbed by distance. But outside the galaxy, there is no shelter. Earth would be exposed directly to a constant rain of high-energy particles, invisible, relentless, unstoppable. These particles would pass through the atmosphere, through rock, and through living tissue. DNA would break apart faster than it could reliably repair itself. Cells would mutate uncontrollably. Cancer would not be a rare disease, it would be a rule. Now consider Earth's magnetic field. Our planet's magnetic field is generated by molten iron moving deep inside the core. It shields us from solar winds and cosmic radiation. But magnetic fields don't last forever. They require energy. They require stability. In a harsh radiation environment, that field would weaken faster. And once it weakens, the atmosphere begins to peel away. This has already happened once before. Mars. Mars once had rivers, lakes, possibly oceans, but it lost its magnetic field, and without it, solar radiation stripped its atmosphere into space. Outside the Milky Way, Earth would face a similar fate, only faster, much faster. Surface life would retreat underground. Deep caves, subsurface oceans, shielded environments. Life wouldn't flourish, it would hide. And hiding changes everything. No complex ecosystems, no large organisms, no stable food chains, just survival. Even the sun becomes a problem. Inside the galaxy, stellar environments are predictable. Outside it, gravitational influences change. Passing objects, rogue stars, intergalactic debris could disrupt orbits without warning. A slight change in Earth's distance from the sun could freeze the planet or boil it. There would be no galactic structure to smooth out these disruptions, no order, just randomness. And randomness is the enemy of evolution. Evolution needs time, consistency, long stretches without catastrophe. Outside the Milky Way, those stretches are rare. Extinction wouldn't be an exception, it would be the default state. Now imagine intelligence trying to emerge in this environment. A species struggling just to survive radiation has little energy left for curiosity, for technology, for looking up at the stars and asking questions, because there would be no stars to look at. The night sky would be almost black, not poetic black, empty black. No constellations to map, no predictable motions to study. Astronomy would never exist, navigation would never evolve. The universe would offer no clues about its own structure. So even if life survived, it would likely remain simple, hidden, unaware. a planet alive, but never awakened. And that leads us to a deeper realization. Galaxies don't just enable life, they enable meaning.
Time, isolation, and cosmic poverty. Galaxies are not just places, they're processes. They recycle matter, reshape energy, and quietly guide the long-term evolution of everything inside them. Without a galaxy, time still passes, but it stops working in your favor. Inside the Milky Way, matter is constantly reused. Stars are born, stars die, their remains seed new generations. This recycling enriches space with heavier elements, the raw materials for planets, oceans, and life. Outside a galaxy, this process collapses. No nearby supernovae, no stellar nurseries, no renewal. Just slow, irreversible depletion. This is what scientists call cosmic poverty, a universe with resources so limited that complexity becomes almost impossible. Time behaves differently here, not physically, but biologically. Evolution depends on long stability, millions of years without disaster, billions of years without collapse. Inside a galaxy, those windows exist. Outside it, they close. Random events dominate. Passing radiation bursts, gravitational disturbances, environmental instability. Life never gets a long enough runway to build anything complex. And then there's light. Inside the Milky Way, the sky is alive with information. Stars move predictably. Patterns repeat. Cycles can be observed. These patterns are the foundation of science. They allow civilizations to track time, measure distance, and understand cause and effect. Outside the galaxy, the sky offers no structure, no repeating landmarks, no reference points, just distant smudges of light, so faint they barely register. The universe becomes unknowable, not because it is mysterious, but because it provides no feedback. This changes something profound. Civilizations don't just need intelligence, they need context, a sense that the universe responds when you ask questions, that it follows rules you can observe. Without that, curiosity fades, exploration never begins, even technology would stall. No stars to navigate by, no reliable cosmic clocks, no predictable phenomena to measure. Science would never move beyond survival. And perhaps the most unsettling consequence, insulation becomes permanent. Inside a galaxy, even distant stars feel connected. Outside it, everything feels infinitely far away. The universe expands, space stretches. Any chance of ever encountering another civilization disappears almost immediately. Not because others don't exist, but because distance wins. So Earth, alone in intergalactic space, would not just be isolated physically, it would be isolated historically, cut off from the cosmic story that gives time meaning. And that leads to the final question. Even if life survives, even if intelligence somehow appears, what kind of civilization could ever grow in a universe like this?
Could intelligence ever truly emerge? Intelligence is fragile. It does not appear just because life exists. It emerges only when conditions remain stable for a very long time. On Earth, intelligence took nearly 4 billion years to arise. 4 billion years of relative calm, predictable cycles, reliable energy from the sun, a sky that changed slowly enough to be understood. All of that depended, quietly, on the Milky Way. Now imagine trying to build intelligence outside a galaxy. In intergalactic space, life would live on the edge of survival. Energy would be scarce, radiation would be constant,
Extinction events would be frequent. Under these conditions, natural selection favors one thing above all else: simplicity. Simple organisms survive chaos better. They reproduce faster. They recover more easily. Complexity becomes a liability. Large brains require energy, long childhoods, stable environments. Outside the Milky Way, those conditions almost never last. Even if a species somehow developed awareness, its world would offer no encouragement. No stars moving in patterns, no cycles to measure, no predictable universe to decode. Curiosity depends on feedback. You ask a question, the universe responds. Without that response, questions stop forming. Now consider communication. Civilizations grow by sharing ideas across generations, across cultures. But in a world constantly under threat, knowledge becomes fragile. Libraries burn, records decay, history resets, again and again. Progress stalls. And then there is the sky. On Earth, the night sky inspired navigation, calendars, mythology, science. It gave early humans a sense that the universe was structured. Outside a galaxy, the sky offers nothing, just darkness. No sense of direction, no indication that anything exists beyond your planet. The universe feels small, not because it is, but because it reveals nothing. A civilization born under these conditions would likely turn inward, focused on survival, not exploration, practical, not curious. Advanced tools might still exist, but the deeper questions about origin, destiny, and meaning might never be asked. So the most unsettling possibility is not that life fails, it's that life succeeds but never awakens. A living planet with no astronomers, no physicists, no one to look into the darkness and wonder what it means. And that brings us to the final realization. Earth's intelligence was not inevitable. It was enabled by time, by stability, by chemistry, and by a galaxy that quietly supported all of it.
Why our galaxy matters. Earth does not simply orbit the sun. It belongs to something larger. A galaxy that provided raw materials, shielded us from chaos, and gave life the time it needed to grow. The Milky Way was never just scenery in the night sky, it was a silent partner. Without it, Earth might have been a barren rock, or a planet struggling in isolation, or a world where life never learned to look up. Not because the universe is cruel, but because complexity requires context, and context comes from environment. When we imagine Earth outside the Milky Way, we aren't imagining destruction, we're imagining absence, the absence of structure, of renewal, of connection. A universe that offers no clues and asks no questions back. Our galaxy gave us something rare, not just stars, but balance. Enough energy to drive chemistry, enough protection to preserve atmospheres, enough stability for evolution to experiment. Over billions of years, that balance turned simple molecules into oceans, into ecosystems, into minds capable of reflection. When you look at the Milky Way tonight, you're not just seeing distant stars, you're seeing the environment that made your existence possible. Every element in your body was forged in stars like those. Every thought you've ever had depends on time, and time depends on stability, and stability begins on galactic scales. We often imagine ourselves as explorers of the universe, but before we could explore anything, we had to belong somewhere. The Milky Way was that place. Earth's greatest advantage was never its intelligence, It was never its technology. It was where it started. And in a universe this vast, that might be the rarest gift of all.